Hello learners, welcome to this course on Embedded System Design using Raspberry Pi 4 module. So in this series of lectures, I am going to discuss about the Raspberry Pi 4 computer. So we'll be talking about its pinout details, architecture, and also we will be describing about the programming part. How to interface different peripherals with your Raspberry Pi 4 module. So let us start the first tutorial in which I am going to discuss about the features and the different types of Raspberry Pi module which is available in the market. So a Raspberry Pi is a series of small single board computers. So it can act as a standalone computers. So it is developed in United Kingdom by the Raspberry Pi Foundation in association with the Broadcom. So Broadcom is a company which manufactured the processor IC for this Raspberry Pi module. So it's a small size, low cost computer that can connect to a computer monitor and we can use it for processing. So there are different variants of Raspberry Pi modules. So since its inception in 2012, we have lot of module variations in terms of a processor and its memory capacity and its processing power. So initially the Raspberry Pi B model, which has a memory capacity of 256 MB, was introduced. Then we have other variants like A plus with different memory capacities. Then came your Raspberry Pi 2B with 1 GB memory capacity. Then they introduced Raspberry Pi 0 with a 512 memory capacity, 1 GB memory capacity. Similarly, Raspberry Pi 3, 4, 5 has been introduced. So in this series of lectures, I am going to talk about this Raspberry Pi 4 module, where we can have the memory capacity in terms of your 1 GB or 2 GB or 4 GB versions are available. So we are going to especially deal with this module and see how we can interface the different peripherals with this Raspberry Pi 4 modules. Now let us look at the features of this Raspberry Pi 4. So the important heart of this Raspberry Pi 4 is your controller. So here we have a Broadcom BCM2711 IC, which is a quad-core 64-bit ARM Cortex A72 processor. So quad-core represents we'll be having 4 cores, 4 CPUs, and all the 4 CPUs are capable of executing 64-bit operations, 64-bit arithmetic and logical operations. And this processor is built on your ARM core. So ARM processor is a software IP and this is used in this IC. And the variant of this ARM processor is Cortex A72, which is an application based processor. And this processor will be running at a speed of 1.5 GHz. In addition to this processor, this Raspberry Pi 4 module has a memory, RAM memory, which is a LPDDR4 RAM memory, which is a low power double data rate 4th generation memory. So it can support a 1 GB RAM, 2 GB RAM or a 4 GB RAM. Then we have a video codec. So two different standards of video codec are supported by this Raspberry Pi. One is H.265 and H.264. So this H.265 is a HEVC, which is a high efficiency video coding system. In order to do your video processing, we make use of this standard. So here we can have something like 4K pixels can be supported. In a video frame, we can have up to 4K. 4K in the sense 4024 pixels can be supported with a frame rate of 60 frames per second. A video with a 60 frames per second can be supported using this H.265 codec. Similarly, using this H.264 decode, it can support a HD type of videos, 1080p60 type of videos. So 1080p60 in the sense the video resolution will be in terms of 1920 by 1080 pixels in a frame, and it can support 60 frames per second. So these two modules, H.265 and H.264, are video codecs for helping in video processing. Then we have a video core, 6th generation 3D graphics. It is mainly used for your multimedia applications. So it consumes very low power and it is used in your mobile multimedia processor. This Raspberry Pi 4 module also supports a dual HDMI display output port where we can connect an external monitors. So external monitors which supports a pixel value of 4K with a frame rate of 60 frames per second can be interfaced using this dual HDMI display port. Then we have connectivity using wireless LAN IEEE 802.11 AC. A wireless local area network can be established, and this local area network can be connected using either a 4 GHz frequency or 5 GHz frequency. Similarly, this module also supports a Bluetooth based communication, Bluetooth 5.0 and Bluetooth low energy based communication. So we can connect one SD card to store our programs and for helping in data storage. Then we have two micro HDMI ports which can support a display. We can connect a dual displays with a resolution of 4Kp60 resolution. Two USB ports are available with 2.0 and two USB ports with USB 3.0. So the speed of data transfer is going to vary between your USB 2.0 and USB 3.0. Then we have OpenGL ES 3.0 graphics, which will help in rendering a high quality videos. It is mainly used for graphical processing in game development and also in motion capturing. We can be able to make use of this OpenGL ES 3.0. Then we have a 1 gigabit Ethernet port which can be used to transfer the data at a high speed. Then we have one Raspberry Pi camera port with 2-lane MIPI CSI. So MIPI stands for Mobile Industry Processor Interface, and this interface is used for interfacing a camera to the Raspberry Pi module. Same way, we also have one Raspberry Pi display port with the 2-lane MIPI DSI interface. So here also this MIPI stands for Mobile Industry Processor Interface for display. Then we have about 28 GPIO pins. Out of this 28 GPIO stands for General Purpose Input Output pins. Out of this 28 GPIO pins, we have multiple pin support for communication as well as audio processing outputs. So each GPIO pin has alternate functions. So it can have up to 6 different alternate functions. So we have a universal asynchronous receiver transmitter, which is a serial communication protocol. We have 6 such UART can be supported. Same way we have inter-integrated circuits. Again, it is a serial synchronous communication. Again, we have 6 number of I2Cs. SPI is serial peripheral interface. Again, it's a serial communication protocol. Here we have 5 numbers. So this UART is a 3-wired protocol. So I will have a transmitter line, receiver line and ground line. So our signal will vary in transmitter and receiver line with respect to ground. In case of an inter-integrated circuits, it's a 2-wired protocol where we will have SCL and SDA, serial clock and serial data. In a SPI protocol, it's a 4-wired protocol where I have SI, DO, or we can write it as MI, SO, MO, SI, which is MISO stands for master input slave output. MOSI stands for master output slave input. Then we have a clock, serial clock, and then I have a slave select line. So it's a 4-wired protocol. So MISO, master input slave output, which means which will act like a receiver line. In case of a MOSI, master output, for slave it is input, which will act like a transmitter line. And these signals will vary with respect to the clock signal, and there is a slave select signal to select the device to which the data transfer is going to happen. Then we also have another bus protocol called as SDIO. So SDIO stands for Secure Digital Input Output Port. So this bus can be used for interfacing different devices between a host and multiple devices. Then we have one DPI, parallel RGB display interface. We can able to connect a display through this port. Then we have one PCM. PCM stands for pulse code modulation. After performing pulse code modulation, the data can be transmitted using your I2S protocol. So this I2S stands for inter-IC sound, which can be used for transmitting your audio information. Then we have two PWM channels. PWM stands for pulse width modulation, and it is mainly used for generating a square wave with different duty cycles. Then we have 3 general purpose clock outputs, which can be used for providing clock to other devices connected to your Raspberry Pi. So these are the features available in your Raspberry Pi 4 module. So you can see the capability of this single board computer. So it has lot of memory, a very strong processor, and also it has a lot of peripherals embedded into it. So complex applications can be built using this Raspberry Pi 4 module. So we will discuss one by one, and we will try to see how maximum we can able to use this Raspberry Pi 4 module in the design of embedded systems. Thanks for watching. Please subscribe for more technical learning. And the complete project details, whatever the simulation part, hardware part, interfacing, will be posted in this GitHub repository. You can make use of this repository. Thank you.